In this lesson, we're going to look at solving systems of linear equations. So we are moving away from inequalities for a little bit and then just now focusing on equations. There are three ways to solve for a system of equations. You can graph, you can do the substitution method algebraically, or do the elimination method algebraically. So in this lesson, we're just going to focus on graphing, and then we'll look at the algebraic techniques in another lesson. For this first example, we're going to graph the line and the parabola, and we're using a linear quadratic system, which means one equation is linear and the other equation is a quadratic. So we're going to graph both, and then the solutions of the system is going to be the coordinates of the intersection points. If we see that there are two intersection points, then we know there's two solutions. If there's only one intersection point, then we know it'll be one, and so on. So the first thing we're going to do is graph. I'm just going to draw in our x and y axes first. Our first graph is a linear graph. It's 2x minus 4. So that negative 4 is our y-intercept. And this 2 here is our slope. That's rise 2 over 1. Also down 2 over 1. So I'm going to connect these points to get my line. I'll put arrows on each side to indicate they are going on forever. My next graph is going to be a quadratic. The vertex is at 0, negative 4. And then we can find another point maybe at negative 2 and 2. Do a table of values here. Say I'm just going to put in 2. We're going to get 2 squared minus 4, which is 0. I'm just plugging it back into this y equals x squared minus 4 to find the y value. So that means I have a point at 2, 0 and negative 2, 0. Seems like I have enough points, so I'm going to connect them and then extend them a bit. So those are our two graphs, and now we're going to look at the intersection points. So that's when those two graphs cross each other. So it happens over here and over here. This is the solution to our system of equations. So one point is going to be 0, negative 4, and the other point is at 2, 0. So we have two solutions. When you state your solutions, don't really state them as a point. I would rather you state them as x equals something, y equals something. So for our first coordinate, we have x equals 0, y equals negative 4. And our second coordinate, we get x equals 2, y equals 0. And that would be our final answer. Our next question is a quadratic system of equations. That means we have two quadratic equations. We're going to graph both parabolas, and whatever intersection points we get, those are the solutions. And then we can see how many solutions are possible, which is the number of intersection points. I'm going to go ahead and draw in our x and y axes. If you take a look at our first graph, we have x squared minus 16, which means that my vertex is going to be at 0, negative 16. I'm going to go down by 2's. And we're going to have a vertex at 0, negative 16. Now, be careful with the next points that you draw because we did go up by 2's. So my next point, if this is 1, my x-axis is going up and down by just 1. Next point is going to be at 1, negative 15. And the other one's going to be at 2, 4, 2, negative 12. And negative 2, negative 12. And if you're unsure about what points you're going to have, you can always do a table of values on the side here. So this is for our first equation. So we had points at 0, negative 16, 1, negative 15, 2, negative 12. And we can continue even further and find one at 3 and 4. So at 3, we're going to have 3 squared minus 16, which is 9 minus 16, and that's 7, negative 7. Should be about right there. Same thing's going to happen on the other side. Then lastly for 4, that's 4 squared minus 16, which is 0. So we have a point at negative 4, 0, and positive 4, 0. So that's our first quadratic. Now we can look at the other one. We definitely have a vertex at negative 4, 0. And let's find some other points. So we can do negative 3, negative 2, negative 1, and 0. And then find the corresponding y value. So that will be 1, negative 1 on each side between negative 5 and negative 3. I'll do the next one. This is going to be 2 squared times negative 1, which is negative 4. Plot that in there on each side. Negative 1's next one. That is 3 squared, negative 9 then. And then lastly, 0, which is going to be negative 16. Because that's 0 plus 4 squared, which is 16, multiplied by negative 1 is negative 16. Now we're going to connect our points to create that quadratic. It's like something like this. Now we'll look at the intersection points. So there are 2 points that are 2 graphs are intersecting at negative 4, 0, and at 0, negative 16. So our coordinate points are negative 4, 0, 0, negative 16, and when we state them, it's x equals negative 4, y equals 0, and x equals 0, y equals negative 16. So in summary, when you're solving for a system of equations, graphically, you're going to graph the 2 equations and then find their intersection points. Those coordinates are going to give you your x and y values, and those are the